Hello students, how are you doing? This is me again, Sir Novero, and welcome to my YouTube channel, Mike Matic. For today, we'll be discussing all about um, arithmetic sequence. But before that, let's head to the problems that are related to arithmetic sequence. Okay, so for example, person is considering two job offers. Company A will initially pay 150,000 pesos a year with a guaranteed raise of 5,000 pesos each year. Company B offers a starting salary of 160,000 pesos a year but will only guarantee a raise of 2,000 pesos a year. If we put this into a tabular form, what could be the possible image of the table? Okay, so here is the table. So the first row, those are the years that you are going to work, and second, third row are the salary for company A and company B. That's with the additional or the guaranteed raise for each year. In company A, you started with 150,000, and then every year you are guaranteed a raise of 5,000 pesos each. 5,000 pesos. So from 150,000 first year, second year 155, 160,000, 165, 170, 175, and so on until the 10th year 195. While company B, you started with 160. Second year, you will have a raise of 2,000 pesos, so that's 162, and another year 164 and 166, and so on and so forth. So if that person is you, which offer would you take? Would you grab? Okay, so again, imagine the relationship of these figures there. How would it affect us, okay, in our decision, in our problem solving skills, right? Okay, so these types of problems involves arithmetic sequences. Okay, the relationship of the numbers and the similarities they have. It pertains to an arithmetic sequence. Okay, so what is an arithmetic sequence or arithmetic progression? Because each term after the first differs from the preceding term by a constant value. Okay, so as you have noticed from company A, you have first term 150, and then there's a raise every year, so that's 5,000. Okay, that's the constant value there. Okay, that's why it's arithmetic. So what are the other examples of arithmetic sequences? You can have the counting numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. What else? The even numbers, the odd numbers, right? Okay, so proceed. Arithmetic sequence is a sequence, this is the same thing earlier. Difference between consecutive terms is called the common difference of the sequence. Okay, again, it's called the common difference, which we usually notate as D, letter D. Okay, and then we'll have an example here, number 1. Okay, so identify the common differences among A, B, and C. Identify the common difference in each sequence. So let's put it to tabular form here. Okay, so first is 5, 10, 15, 20. So for you to get the common difference, you subtract the second term by the first term. Yeah. Okay, so subtract second term by the first term, so it becomes 10 minus 5, that is 5. So the common difference is 5. subtract 2 by 5, that is negative 3. Subtract 3 halves by 1, 3 halves minus 1, that is 1 halves. Subtract 3 and 3/4 by 4, that is negative 1/4. And then here, a sub 1 plus 2d minus 1, that is a sub 1 plus 2d minus a sub 1, I mean, is equal to, you're just going to cancel a sub 1, so you will come up with 2d. Okay? Next, example number 2. Write the first 6 terms of the arithmetic sequence with the given first term 6 and common difference negative 2. Okay, so first term is 6 and the difference is negative 2. So you add negative 2 to the first term 6 and obtain 4. And then we add negative 2 to get another term. To 4 we'll have 2. In the fourth term you will add 2 with negative 2, so you get 0. And then the fifth term you'll add negative 2 to 0 again, so your fifth term is negative 2. And then your sixth term is negative 2 plus the negative 2, which is equal to negative 4. Okay, do you follow? Okay, thank you. First 6 terms are 6, you include also 6, and plus negative 2 you'll have 4, 2, 0, negative 2, negative 4. 6, 4, 2, 0, negative 2, negative 4. Okay, so keep on adding the common difference with the preceding terms. Okay, now with the following examples we had from 1 and 2, we can now make a generalization for an arithmetic sequence whose first term is a sub 1 and whose common difference is d. What I mean is, we're going to make an explicit formula for this particular sequence. Okay, so let's derive it from the very beginning. So your a sub 1 is the first term, so it's just a sub 1. Then when you get the second term, what did you do? Okay, correct, you added the difference, right? A sub 1 plus d. Added the difference to the first term for you to get the second term. And for you to get the third term, you add twice of the difference from the second term, first term. Or here you can add another d for the second term there. Then you may substitute. Okay, so the a sub 2 here is just from this one, right? That's why it's substituted here. And then you get a sub 1 plus 2d, right? 2d. Next, for the fourth term, you get the a sub 3 plus d, and then your a sub 3 is here, so you substitute it here. And then you will add again a sub 1 plus 3d. And then in the fifth term, you add another d for the fourth term. Okay, so you substitute the third term here, and then you add another d, so that's why a sub 1 plus 4d. And then the sixth term, you add another d for the fifth term. And then you substitute the value of a sub 5. Then you come up with a sub 1 plus 5d. Now, what have you noticed with the coefficients of d here? So is it increasing or decreasing? So starting from 0, 1, 2, 3, 4, 5, right? So it's 6, and then it's 5 here. 5 here, the n here is 5, and then here it's 4. And it's a sub 4 fourth term. Here it's 3. A sub 3 is 2. A sub 2 is 1. A sub 1 is 0. Now, with that, we can conclude that the n here, or the 6 here, is subtracted by 1, right? So it's 6 minus 1. How about here? 5 minus 1. See, to get 4. And then here, 4 minus 3. And for that, we can now conclude that a sub n, nth term, we don't know the term yet, is question mark. Thus, the formula with that particular example and conclusion earlier that we only subtract 1 from here, this one. Therefore, the formula is nth term is a sub 1 plus a quantity n minus 1 times d. Alright, do you follow? Okay. Hence, the nth term general form of an arithmetic sequence with the first term a sub 1 and the common difference d is a sub n equal to a sub 1 plus n minus 1 times d. Okay, let's take, for example, this thing here. Find the a sub 30, the 30th term in the arithmetic sequence -4, -1, 2, 5, dot. Okay, so for you to get the a sub 30, you what? Identify the first term, get the difference, which is 3, and then what number is being asked, or what's the value of n, which is 30, and then plug into the formula, right? The formula, the n, or the explicit formula, the nth term general form of an arithmetic sequence. And then you plug in those values here, substitute, so -4 for a sub 1, and then 30 minus 1 times 3, so you'll have -4 plus 29 times 3, -4 plus 87, which is a sub 30 is 83, or the 30th term is 83, right? Okay, in the sequence, in example 3, what is n if a sub n is 503? So you are asked to solve for n given the nth term. You don't know the value of n yet, okay? So you identify first what are the given, and then you use the same formula. So the same sequence used. Okay, a sub n, you don't know n yet, so you're just going to solve for n, and then 593, and then a sub 1, the same a sub 1, the same difference, so you're going to solve for n. So solution, you write the formula first, and then you substitute the given values. So this one here is, which one is missing? So it's n, not the a sub n this time. So from here, place this one here, then the a sub 1, n is missing, so it's written only here. Okay, so you multiply, distributive property. Okay, and then you simplify, combine numerical terms. So -4 minus 3, you get -7. And you add 7 to both sides, you'll have 593. Plus 7, you'll have 600. And then divide both sides by 3, you'll get 200 equal to n. Okay, so since n is equal to 200, therefore, then 593 is the 200th term of the sequence. Do you want to practice? If you want to watch you may pause this part for practice exercises. If you want to check your answers, you can have this answer keys.